Greetings to all the viewers. The session is going to continue with the alkaloids. Alkaloids are the part of natural products. This is the content retrieved from textbook of natural products nurturing livelihood. So the textbook, from this textbook, we are conducting series of sessions based on these natural products. All are available at the channel called World of Competitive Chemistry. Now we are going to discuss about the compound called ephedrine. Let me introduce the compound alkaloid ephedrine. Introduction. Ephedrine is naturally occurring phenylamine alkaloid. Phenyl, what phenethylamine alkaloid obtained from the plant of the genus Ephidra-Sinica. Ephidra-Sinica is the kind of plant kingdom from which you are able to extract this ephedrine plant, right? Here, Ephedra sinica is available over there. You can clearly observe the plant from which ephedrine is economically extracted. If you want to know about IUPAC nomenclature, IUPAC means for International Union for Pure and Applied Chemistry. IUPAC name of naturally occurring isomer commonly known as minus ephedrine, 1-ephedrine, 1R2S methylamino phenyl propane 1-ol. So this kind of naming is indicated. Let me repeat once again. 1R2S methyl, 2-methylamino, 1-phenyl propane 1-ol is the IUPAC name of the compound. This chemical compound is a substituted aromatic alcohol that acts as a sympathomimetic stimulant and bronchodilator. So it is a kind of bronchodilator. Bronchodilator deals with the lungs. So it is the kind of material which deals with the lungs. It is structurally related to adrenaline. Adrenaline is a kind of secretion given in the body. So within the body, glands are able to secrete adrenaline. Gland able to secrete adrenaline. So that used to regulate the blood pressure. So ephedrine structurally resembling with this adrenaline and belongs to the class of sympathomimetic amines. So here also sympathomimetic amines are located within the molecule. Structural features of this ephedrine, it is the kind of benzene ring. Aromatic benzene ring is the kind of skeleton which present within the ephedrine molecule. Secondary alcohol is also located. Hydroxyl compound that is secondary in nature is also present. And another essential functionality, nitrogen, is present in the form of secondary amine. N-methylated amine, that is secondary amine. Chiral compound, it will be being carbon surrounded with 4 different functional groups is said to be chiral. That chiral nature is also located for this kind of ephedrine exists as a stereoisomer. Stereoisomers, being it is a chiral, there is a possibility of the stereochemistry. This is the way its structural features are provided. Benzene ring will be their secondary alcohol and secondary amine are the important parameters which are present within the ephedrine molecule. Negative ephedrine minus ephedrine will be taken. Levorotatory it will be. And you can clearly observe the benzenoid nucleus. Here is the secondary hydroxy. Here is the methyl. And this nitrogen is present in the form of secondary amine in methylated form. Very simple chain containing aromatic benzene ring is present for this ephedrine potential in the case of medicinal applications. What significance you can observe for this ephedrine molecule? Alpha beta adrenergic receptors. So being it is resembling with the adrenaline gland, adrenaline secretion. So alpha beta adrenergic receptor, it works like, right? Direct action upon the receptor stimulation, right? Wherever action required within the living organism, there it able to activate that particular region, that particular organ. So that is called a stimulation. So direct action taking place upon that particular organ. Indirect is also possible releases. Neuropinephrine. Neuropinephrine release is possible. So this is the way also it able to show its adrenergic property. So these are the pharmacological activities of this ephedrine molecule. Then physiological effects within the living organisms, how it show the impact on the living works. So lively works, that means metabolic activity, how they are affected by means of this ephedrine. Bronchodilation. Bronchodilation is nothing but the people who are suffering with asthma asthma conditions, what happened that kind of windpipe will be totally contracted, so that breathing will become very problematic. Inhalation, exhalation may not be possible sufficiently. That is the reason why lung pumping will be slightly lowered and its efficacy will be minimized. At that condition, if the people are consuming this ephedrine, that used to elevate, that used to elongate the size of the windpipe, so it becomes very easy for the respiration process. Inhaling oxygenated air and exhaling carbon dioxide containing air is possible in the sufficient and comfortable manner. That is said to be bronchodilation. This is the way ephedrine is working effectively against the asthma conditions. Increased heart rate. The people who are suffering with the lower functioning of the heart is very essential. Blood pumping system, it will be just like motor. How motor will pump the water, in the same manner heart able to pump the blood to the entire organs of our body. Especially brain requires the larger blood circulation, larger oxygenated blood circulation in order to make the active thinking, active working of that one. Along with that, remaining all the organs, even minute tiny organs also require the circulation of blood in the sufficient manner. So this is the way oxygenated blood will be pumped, and contaminated carbon dioxide containing will be taken back, and that will be exhaled. This is a process taken by the heart functioning. So that heart functioning, if not in the sufficient way, what happens, that entire circulation system will be totally damaged. That may induce a kind of various diseases. In order to avoid all these, heart functioning will be regulated by means of this ephedrine. And not only the kind of lung functioning, heart functioning, but also nervous system, right? Ephedrine consumption will elevate the action of nervous system, central nervous system, activated by means of ephedrine alkaloids, so that that kind of nervous system proper working is possible. That is only required for entire activities of the human beings or any living organism being. All the activities got controlled by the central nervous system. So here the CNS activation will gives rise to the active part of all kind of activities. All organs will work in a harmonical and effective manner. Then vasoconstriction, it is also related with the heart functioning only. There also again, heart rate will be got regulated, and that proper functioning of heart is possible by means of this ephedrine. This is the way. Very essential applications indicated for this drug called ephedrine. Important drug in the respiratory and cardiovascular therapy. As we already discussed, bronchodilation is the kind of condition, and increased heart rate is also the condition applied by this ephedrine. That's the reason why respiratory system and cardiovascular system will be positively impacted, and they effectively curated by means of the alkaloid called ephedrine, right? So this is about the physiological properties of that one. If you clearly observe this asthmatic condition, if the asthma is there contracting, this windpipe is uh, totally contracted. The size of that pipe is very infinitesimal, so that air movement will become very difficult with tiny hole. So if we are consuming this ephedrine in the sufficient quantity, what happens, that elongation, that kind of increase in the width of that diameter of the windpipe, so that air circulation will become convenient, and that will increase the functioning of lungs. Respiration will be effectively enhanced. This is the way asthmatic conditions effectively curated by means of that ephedrine. Ephedrine being, it is the uh, kind of natural product. Ephedra sinica is the genus plant from which you are able to extract this one. So that extraction process is very important. Just let me take that kind of compound from the plant in a systematic manner. So that is said to be isolation and extraction process. Ephedrine is isolated from Ephedra species using alkaloid extraction process. Alkaloid extraction taking place from the Ephedra species, right? What procedure you are going to apply? powdered plant material to be taken. So first of all, Ephidra-Sinica to be taken, and that should be properly dried and powdered. That powdered plant extract to be taken and added with dilute acid. Obviously, ephedrine is the kind of basic one with a nitrogen atom. So dilute acid is the suitable one in order to neutralize. Later on, salt will be filtrated. Acidic extract contains alkaloid salt, right? So filtration giving rise to a kind of filtrate. Filtrate is a discarded one only, whichever generated in the solid form, that is in the salt form, being as acid and ephedrine base will be forming a salt one, which is in the form of solid one, that will be filtered effectively. Later on, we need to add the sufficient content of alkali, either sodium hydroxide or ammonium hydroxide. Any of the base, strong base or mild base, can be applied for the basification. Whenever basification is carried, free base extracted with the organic solvent, here you are supposed to apply either ether or else chloroform. Ether, chloroform are the organic solvents, right? So that the convenient extraction of ephedrine into this solvent taking place in the form of liquid, and leaving all the solid impurities, other contaminants into the in either discarded one only, so that here ether chloroform effective for the extraction of ephedrine. During the extraction and isolation process, suitable solvent selection is very important. After extracting this one, what happens? Just extracted to be taken in the petri dish, so that ether will be conveniently evaporated within shortest span of time, and leaving all the solid of ephedrine within that dish only. So that is the process of extracting material without adding with any contaminants over there. After getting that one, still we need the highest quality, highest purity of that one, and moreover crystallization is also required. In order to get that recrystallization process, will be applied either ethanol or methanol will be mixed, and a pinch of charcoal will be added and heated under water bath, so that adsorption taking place, all the impurities will be adsorbed onto the surface of that charcoal, and pure form of crystals, ephedrine will be separated in the form of crystalline form. This is the purification is possible from this Ephidra-Sinica plant. The entire process provided in the diagrammatic representation, process of extraction and isolation of ephedrine taking place by the amount of Ephidra-Sinica plant to be taken. Here you can notice Ephidra-Sinica plant. So whose what some plant materials to be taken, dried and powdered first. After getting that powdered form of that one, that should be treated with a suitable solvent over here. Either ether or chloroform can be taken. Vacuum filtration is applied. First of all, we need to add the acidic solution. Whenever acid is added, here the salt formation is possible. That salt will be filtrated by this Buckner funnel. So vacuum filtration is applied over there. Whenever vacuum filtration is possible, solid left over the top region and the filtrate will be discarded one. So dried and powdered form of that material, whichever collected on the Buckner funnel, to be indicated over here. Later, ammonia is added. So slight basification is required. Either ammonia or sodium hydroxide to be mixed with this one. Whenever mixed, now its neutral form will be transformed into a kind of basic one. Alkaline ephedrine solution will be generated. Ethanol should be added. Ethanol able to extract that material into that organic layer, and the slurry was made. The kind of paste material will be generated. Now we can treat with sodium carbonate solution, and finally, if you filter and evaporate that one, you can obtain the crystalline form of that ephedrine in the purest form. So this is the entire extraction process is provided. Now let me indicate the very important step for this ephedrine alkaloid will be the biosynthetic pathway. So being it is a natural product, how it can be synthesized within the plant material to be understand. In that purpose, biosynthesis of this ephedrine is discussed in detail. The biosynthesis is accomplished by phenylalanine pathway. Phenylalanine is the kind of amino acid, being it is the precursor for this ephedrine alkaloid. Phenylalanine pathway can be adopted. So phenylalanine taken as a starting material where you can have carboxylic acid and alpha amino functionality over there. That should be heated slightly in order to remove the carboxylic acid by means of decarboxylation. Decarboxylation of phenylalanine giving rise to only phenethylamine formation is possible. Only amino left, carboxylic acid discarded by decarboxylation. Now it should be performed with hydroxylation and methylation. It is added with hydroxyl functionality and methylating agent to be added. Whenever hydroxylation and methylation are performed over this phenylamine, so that here ephedrine is the final product. Let me indicate in the systematic representation of this formation of ephedrine, starting with this phenylalanine as a precursor compound, as a starting material. Phenylalanine is sufficiently alpha amino acid. You can notice carboxylic acid, and here the amino functionality will be present. So that will be dehydrated, so giving rise to transacinamic acid. Transacinamic acid will be generated. Later on, we are supposed to go for hydration process. Hydration means addition of water, so that here the hydroxyl group, here the hydrogen will be added, giving rise to hydroxyphenyl propionic acid will be generated. So whenever this molecule is supposed to be cleaved over there, so here this carboxylic acid will be fragmented, and whatever benzene with hydroxyl will be converted into a kind of a benzaldehyde called a retroaldol cleavage for process will be applied. Later on, it should be oxidized into benzoic acid. It should be converted into benzoic acid. After getting that benzoic acid, another enzymes should be added over there. Benzoic acid now converted into diketone. Phenyl diketone formation is possible, and transaminase, the enzyme working upon this one will be transaminase. Transaminase is able to generate this amino functionality over this terminal carbon atom, so that here you can notice amino functionality, whichever carbon is there, that is a side chain methyl. And here the molecule generated is called ace-cathinone. Ace-cathinone is the notable intermediate obtained by the transamination process. Next, reductase to be applied. Reductase is meant for the conversion of ketonic functionality into hydroxyl by biotransformation. So here hydroxyl will be obtained. So being it is the kind of chiral carbon, this is also chiral carbon, the stereochemistry plays a role. Here 1 or 2 is nerephedrine. So norephedrine, sorry. 1 or 2 is norephedrine formation is possible. The molecule generated, only the difference between this molecule and ephedrine will be in methylation. Only the step lacking will be in methylation. In order to get in methylation, this free amino will be subjected to N-methyl transferase. N-methyl transferase is able to convert norephedrine into the simple ephedrine molecule, so that N-methylation taking place. This is the way entire biosynthetic pathway will be performed. In the alternative pathway, here the cinnamic acid to be treated treated with the acetyl coenzyme A, so that here the carboxylic acid will be converted into coenzyme A as the terminal active functional group. So here cinnamyl coenzyme A formation is possible. Whichever generated will be further subjected to what? Hydration. Again, here you need to perform the hydration, so that here hydroxyl will be generated. Hydroxyl generated with the terminal coenzyme A active functionality. Further, supposed to go for the oxidation process. This to be performed with oxidation. The generated hydroxyl will be shifted into diketone. 1,3 diketone formation is generated. Later on what we have to do, it should be removed with this carbonylic functionality, and this ring concise chain contraction is possible, and giving rise to this benzene with C double bond ACOA. Coenzyme A will be generated. Benzoyl coenzyme A is the intermediate generated in the alternative pathway. So this is also again converted into a kind of a benzene with a diketonic functionality over the side chain. And again, there is a process of amination and subsequent reduction and subsequent N-methylation, giving rise to ephedrine as the final product. This is about the entire pathway of the biosynthesis. We need to start with the phenylalanine. Phenylalanine is the starting material for the biosynthesis of ephedrine. Ephedrine is the kind of aromatic amine and hydroxyl containing compound where secondary hydroxyl, aromatic benzene rings, secondary amine and methyl functionalities are the important moieties within the molecule. By this, we are going to conclude the session. Hopefully, this is informative for your preparation. If you continue with this preparation, it will give much interest and much information regarding natural products. All are available at the channel called World of Competitive Chemistry. Everybody are requested to subscribe the channel and watch all the concepts which are available carefully so that it will be fetching for your further preparation. Thank you one and all. Thank